Welcome you all. In this session, we are going to see about the swing equation outcome. After successful completion of this session, the student would able to derive the swing equation for single machine infinite bus system. The relative motion between the air gap MMF and rotor speed for any disturbance is described by swing equation. The solution of swing equation will give the variation of power angle with respect to time. A generator receives a mechanical torque input via a shaft from the prime mover and develops electromagnetic torque which opposes the mechanical torque. The algebraic difference between the mechanical torque and the electric torque. Yeah, mechanical torque and the electromagnetic torque is the net torque, which causes the acceleration of rotor. When the machine is operating under steady state, the net torque is zero. When there is imbalance between the mechanical torque and the electromagnetic torque, there is an acceleration or deceleration depending on whether the net torque is positive or negative. If the net torque is positive, it indicates it is acceleration, and if the net torque is negative, then it indicates it is a retardation. So here you can see that Tm represents the mechanical torque. As I told, Tm represents the mechanical torque, Te represents the electric torque, and Ta the net torque. Okay, so Ta is nothing but it is the difference of mechanical and electric torque. And again, by law of mechanics, it can be represented as J into d square theta m divided by dt square. So I can express that. So I can equate all those things. So I'll be getting J d square theta m divided by dt square, which is equal to the net torque, which is again equal to the difference between the mechanical torque and the electric torque. That is why I am representing the equation. Here J represents the total moment of inertia of rotor in terms of kilograms per meter square, and theta m represents the angular displacement of rotor, and Ta represents the net acceleration of torque, and Tm the mechanical torque in Newton meters, and Te the net electromagnetic torque in terms of Newton meter. So here theta m is equal to omega smt plus del m. So now from this I am going to differentiate it with respect to t. So while differentiating it, I'll be getting as, see here it is omega t, and here the differentiation is with respect to t, right? So now so with respect to t is 1, therefore omega sm plus here it is d del m divided by dt. So I'm getting this. So now what I'm going to do is, again further I'm going to differentiate with respect to t, therefore d square theta m divided by dt square, and here there is no t term, so it's a constant, so it becomes 0. The omega sm get vanishes, so I'll be getting d square del m divided by dt square. So now what I can do is, in the previous equation I can replace d square theta m by dt square by d square del m by dt square, right? So I am replacing. So my first equation is, now it can be rearranged as j omega m d square del m divided by dt square, which is equal to PA, which is equal to PM minus PE. So here in the first equation I have represented it in terms of torque. Now I am going to represent it in terms of power. So where PM represents, it is the shaft power input of machine, PE represents the electric power, and Pa is the acceleration power. It is the difference of the mechanical power, that is the shaft power, and the electric power. Okay, similar to that of torque. So now again here j omega m is equal to m. I'm replacing j omega m by capital M. So my equation becomes m d square del m divided by dt square, which is equal to Pa which is equal to Pm minus PE. This equation we call it as swing equation. This is what we call it as what? Swing equation. So this expression we call it as. So whenever we need to write the swing equation, this is what we call it as the swing equation. Here m is equal to 2h omega m sm. So again, now I'm going to replace this m by this expression. So my equation becomes this. On further simplification, I'll be getting it as d del omega divided by dt is equal to pi f naught h pa, which is equal to d square del by dt square. Here h is the machine inertia and del and omega s are in electrical radians. See, so in the previous case, we discussed it for a single machine system, swing equation. Now for multi-machine system, the swing equation, it goes like this. H system divided by pi f d square del by dt square is equal to Pa minus Pa is equal to Pm minus Pe per unit. Here, S machine is machine rating, S system is system base. So I can represent it as H system is equal to H machine into S machine divided by S system. Thank you.